Hi there, this is Reuven Lerner. I am super excited to be making this presentation for you folks at this Train the Trainer session in Nigeria. I met Godfrey last year at PyCon in Cleveland, Ohio in the US. I attended his talk, I really enjoyed it. He came up to my booth, we talked a little bit then, and we've been in touch on occasion since, and it really tickles me pink to be able to participate, perhaps not physically, but at least over the magic of the internet in this session. So first of all, I'm happy to be here. Second of all, I wish you all the best of luck in learning about not just Python, but how to train Python. As you know, in the education business, there is a difference between content knowledge and pedagogical content knowledge. So you might be really excellent at Python, but you might not know how to explain it so well. And so this kind of session where you learn how to explain it, what sorts of mental models will work, how best you can get the ideas across to your students, it'll be great for everyone. A few words about myself. I am based in Israel, in a city halfway between Tel Aviv and Jerusalem called Modi'in, small city. You've probably never heard of it. And I am a Python trainer. I spend just about every day in a different city, a different country, a different company, teaching Python to engineers. Everything from Python for non-programmers, for people who are totally new to the language, to advanced practice workshops. I also have a bunch of online courses that I teach. I have a whole lot of video courses on various aspects of Python. And I also have my weekly Python exercise. You can see here my t-shirt. I think Godfrey has one as well. Weekly Python exercise, which is, as you can imagine from the name, a set of courses. It's currently 6 courses, each of which is 15 weeks long and allows you to practice your Python. You get a new problem every Tuesday, a new answer every Monday, and between the problems and the solutions and the PyTest tests and the conversation in our forum, you get to improve your Python and become better at what you're doing and write less code and do more with it. I'll also mention that I have a bunch of free things that I do. I have a mailing list called Better Developers that goes out to people all over the world, about 15,000 subscribers right now. I'll put the URL here, and I'll be sharing this Jupyter notebook with you so you can pick it up and so there's a Better Developers newsletter. I also have, as of recently, a new free 6-hour video course called ACE Python Interviews.com, and that's going over about 50 different questions that people are asked about in their interviews. And I'm on Twitter, and I'm on YouTube, and I have a blog, and okay, enough about me. Let's talk about Python, and specifically what I want to talk to you about is the consistency of Python. So here's the thing. You have all presumably learned at least one foreign language. For many of you, English is a foreign language, and I'm sorry if I speak quickly. I really am. That's just sort of the way I am. And as you've probably learned when you learn a foreign language, here's how it often works. Here is how nouns work in this language. Oh, except for the following exceptions. And here's how verbs work, except for the following exceptions. Oh, and we have these funny kinds of verbs and those kinds of verbs, and this is how you make it plural, and this is how you make it singular, and this is how you make it past tense and present tense and all that stuff. I'll add, as a native English speaker, I feel very lucky that I was spared the torture of having to learn all the different kinds of verb forms that English has, not to mention the craziness of English spelling, but that's for another time. So people who were learning languages for many years got sort of tired of this, and linguists struggled with it because the more exceptions there are, the more unusual rules there are in a language, the harder it is to learn, the harder it is to remember. And so a number of years ago, I guess about 100 years ago, people came up with the idea of Esperanto. And Esperanto was supposed to be sort of like a new Romance language, and its attraction was that it was extremely consistent. It had no exceptions. Once you learned a rule, it was good. Well, Esperanto didn't really take off as much as its founders sort of hoped it would. They thought that everyone would speak Esperanto, it would make for world peace. They had all sorts of nice ideas there. And you could make a very good argument that Esperanto is very easy for you to learn if you already speak a Romance language. But if you speak any other language, it just seems kind of weird. But that doesn't matter. The point is that Esperanto was designed to be consistent, and the consistency meant that it was easy to learn. And indeed, I've met a few people who know Esperanto to some degree, and they say that maybe the sort of inherent logic is a little weird, but once you learn a rule, you can apply that rule forever. I then thus describe, and by the way, I don't really know Esperanto at all. I've just read about it a little bit. I see as Python in many ways as the Esperanto of programming languages. You can learn a few rules, just a small number of rules, and those rules are applied consistently across the entire language. And so what I want to do now is walk you through a few of these rules so that you will understand Python better. You'll understand what rules are in play, and you can explain that to your students. And once you point these out, you can also say these rules always apply. There are no exceptions to these rules. Now, sometimes that's a little bit of a lie, and I'll mention that here and there. But for the most part, I think it's actually true. And it's part of the elegant beauty of Python that the language really does stay so consistent. So what am I going to talk about with you? Okay, so we're going to first talk about truth. What is truth? So you didn't expect it to be theological or philosophical here, but that's what you're going to get. We're going to talk about identifiers and variables and the LEGB rule. We're going to talk about callables and parentheses. We're going to talk about methods, return values. And finally, we're going to talk about attributes and ICPO. Now, this is a whole bunch of material. We could probably spend hours talking about each one of these topics. I'm going to go through each one relatively briefly, and I hope that this will provide you with a jumping off point so that you can learn more, understand more, and sort of experience this more on your own. So let's start with truth. I sometimes call this a Boolean context. So here's the thing. If I have like x equals ABCD, and then I say if x equals ABCD, and say print, yes, it's what I wanted. And that's fantastic. And sure enough, x equals ABCD, that's good. What if I say x equals empty string? I can say if x equals empty string, print, yes, x is the empty string. And that is also fine. Technically speaking, this works and this works. There's no difference between them. But here's the thing. If I'm checking for the empty string, I can actually take advantage of the fact that everything in Python knows whether it is closer to true or closer to false, right? Every single object can be turned into a Boolean value. That's a true or false. And so what does that mean? Well, it means that I could say if x equals empty string, then print it is empty, right? And then I can say else print it is not empty. I can totally do this, and technically this works. But that's not the Pythonic way. And it's not the Pythonic way because everything knows whether it can be turned into a true or false value. And it turns out that every object in Python, in a Boolean context, and that is saying if statements, is the most common one, not the only one, but the most common one, is true, except for, and we'll say here, 0 of any sort, and we'll say false, and we'll say none, and then we'll say anything empty. So what does this mean? This means that I could do something like this. I could say here, if x, print not an empty string. And I could say here, else, print an empty string. And sure enough, now it knows it's an empty string. Now, this is an interesting, useful technique to know, and it makes your code more Pythonic and everything, but it reflects something deeper here in the language. It means that every single thing knows whether it is true or false in a Boolean context. It doesn't mean that we have turned x into a Boolean. X remains a string. If I say, what's the type of x? It remains a string. But the fact that every single thing can be turned into a Boolean makes for shorter code, clearer code in many ways. Right? So I could just say if x, and what this really means is if it's not an empty string. Now you could argue, wait a second, how do I know that x is a string? Well, okay, you're going to have to check that in your code yourself, and hopefully you'll know from just like getting input from the user. Right? So I could say something like this. I could say here, name equals input, enter your name. And then I'll say if name, print hello name. And else, we'll say print hey, you didn't enter a name. Right, so what's going on here? I'm taking advantage of the fact that an empty string is considered false in a Boolean context. And so right now it's going to say enter your name. If I say Reuven, it'll say hello Reuven. And if I do this again, I just press enter, it'll say, hey, you didn't enter a name. So we can take advantage of this, and you can see that we can take advantage of this with all sorts of objects. So numbers, fine, right? 0 versus everything else. Strings, very useful. Lists, sets, dictionaries. If you're not sure if you got an empty dictionary, you can check it in this sort of way. But it goes beyond that, because if that were just true for built-in types, well, that'd be consistent, but it wouldn't really be that world-changing. But the fact is that every single object, including classes that you create, can define a method, a Bool method, right? Set the Bool method in your class, and your objects can also respond as true or false in an if statement. I'll give you a quick example of this. So if I say here class, person, right? And we'll say here def init self-name equals name. And I can say here def bool self. And this is the method that returns true or false. Well, actually, let me do it without that first. So I'll say here p equals person Reuven, and then we're just going to copy this here, more or less. Say here if p, whoops. All right, if p, then hello p dot name. Hey, you don't have a name. All right, so what we're basically saying is, let's create a new person with the name Reuven, and if this object, if the person object is true, then we'll do that. Now, of course, if the person object Boolean value is true, all right, and so here it's going to say hello Reuven. Well, that's very nice. But what if I do it with an empty string? It's still going to say hello. Why? Because we haven't defined bool. But if I do define that, then I have control over whether an object is considered true or false in this Boolean context. This is def bool self return self name equals that. Or we can even just do a bool of self name. Let's do that. And now, Reuven is true. But if I have an empty string here, then that's actually going to work out just fine. I'm going to do this here, could do this there, and sure enough, we don't have a name. So this rule of everything knowing whether it's true or false in a Boolean context is extensible to every object in the system. And this is how all these different objects do it. How is it true that strings and integers and lists and sets and dictionaries and everything, they know how to be true or false in a Boolean context? Because they've set the Bool method. Okay, onward. Identifiers and variables and the LEGB method. So if I say x equals 100 and then print x, well, let's even make it fancier, x equals x. What's going to happen? Well, obviously it's going to say x equals 100. But the question is why? How do we get to that? And that's because what happened here was I said, show me the value of x. And Python starts searching for x in a very set standard order. It looks for it as LEGB. And that's short for local and closing function, and global, and built-ins. Now, what does this mean? This means basically that Python will always, when you give it a variable, if it's in a function, if it's in a function body, start here. Whereas, outside of a function body, start here. Notice that scoping has nothing whatsoever to do with indentation. Nothing. It all has to do with whether you're in a function or not in a function. So that's an important rule to pay attention to. But the sort of deeper rule here is that if you're in a function body, we start looking for variables here. So Python, are we in a function body here? We are not. So we're going to start looking, is there a global x? There is. And then we print out the value 100. So we start with the local variables. And then if we have a function defined inside of another function, which is complex and advanced, then we look at the enclosing variables, meaning the local variables inside of the enclosing function. Then we look at the global variables defined outside the function. And finally, if we have no other choice, we'll look at built-ins, which is the namespace where most common Python stuff lives. And that would be like string, list, dict, set, len, sum, etc. All right, so what's going to happen is you're always going to search LEGB. And the sooner you can internalize this, and I'll say also, the sooner you can help your students to internalize this, the easier Python code will be to read, write, and debug. I can't tell you how many people, when they encounter the LEGB rule, after really understanding it, say, wait a second, this explains a problem that I had in it's something that I did. I'll give you another example here. If I say x equals 100, and then print, x equals that. But we're actually going to take that away. I'm going to say here def my func. Okay, and we're going to say here in my func, x equals that. I'm going to run my func. Is this going to work? Is it going to print 100? Yes, it will. Because Python says, okay, I'm inside a function body, so we have to check local. Is there a local x? There is not. Is there a function defined inside another function? There is not. So is there a global x? There is. We get the value 100 and we print it out. One last example here. What if I say here, x equals 200? Well, now we have local variable x, and we have global variable x. So inside the function, I can even say here, print before x equals x. And we can even say afterwards. So what's going to happen? We're going to get x equals 100 first. Why? Because in this line, in line 7, Python says, are we in a function? No. So let's look globally. Is there global x? There is. Bam, we got the value. Now we're going to execute my func. What's going to happen? We're going to go to my func's body. Now that we're in a function body, we have to check, is there a local variable x? There is. Its value is 200. We don't even check. The first one wins. So LEGB, we search locally, we found something. We're going to ignore the global variable entirely. But when the function returns afterwards, then what happens? Well, then we're looking once again globally. There is a global x and we're fine. So this is how you can have a variable of the same name both inside a function, outside a function. Not a good idea. Don't do that. But that basically shows how you can do it and how Python is able to handle it. The sooner you understand the LEGB rule, the faster you'll understand how a lot of things in Python work. Okay, onward. Let's talk about callables and parentheses. I can't tell you how many times I've seen this problem in my courses. D equals A1, B2, C3. Let's iterate over the dictionary and print it out. So I'm going to say here for key value in D items, print F string, key, value. So we're going to iterate over the dictionary's items. This gives it to us in pairs. We're going to grab that in our iteration here. I'm going to print it out. Fantastic. That's not the problem. The problem is that people often forget to put the parentheses here. And then they get an error. And the error is built-in function or method object is not iterable. And people say, what? What's going on? So here's the basic thing. When you have parentheses, that means I want to execute the thing before them. I want to evaluate the thing before them. I want to call the thing that's before them. And indeed, things that can be executed or invoked are called callables. So a function in Python is a callable. A method is a callable. And a class is a callable. All those are callables. That's why people will sometimes talk about the int function. It's not really a function, it's a class. But it's callable, so it feels and looks like a function. There's a big, big difference between calling a method and not calling a method. Because methods and functions, and classes for that matter, are just objects in Python. So if we don't put parentheses there, Python won't execute it. It'll just keep it around as an object. And so if I say, what happens in a for loop? For turns to the result of invoking d.items. Oh, that's an object, an items object, and I can iterate over that. I'll get 1 value, 2 values, 3 values. We're doing great. But here, for turns not to the result of executing d.items. It's turning to the method d.items itself and saying, are you iterable? And the answer is no, this method is not iterable. Big, big difference between invoking with parentheses and without. So one of the big consistencies in Python is that functions are objects just like every other object. If you want to execute it, you must use parentheses. I'll give you one more example on these lines. If I say here s equals abcd, and I say let's do x equals s dot upper. What's the value of x going to be after I run this? Well, the x is going to be abcd uppercase. Great. What if I say x equals s dot upper without parentheses? Now what is x? That's right, x is now an alias to s dot upper. In fact, if I say what's x, it'll say, oh, this is function stir dot upper. Well, wait a second. If it's an alias to s dot upper, how can I execute a function? How can I invoke a method? I call it with parentheses. And there we go. Now I get abcd. So you can see that there are actually two things going on here. One is that we are retrieving the method object from s.upper, and then we are invoking it. Two separate stages here, two separate things. And if we break those stages apart, we can do that with parentheses. So you want to use parentheses whenever you want to execute something. You don't want to use parentheses if you don't want to execute it. And this is the key, and we don't have time now to talk about it, but this is the key to how you can actually pass functions to other functions in Python. Okay, another thing, method return values. This is something that actually took me many years to understand, but method return values. If the data is mutable and the method modifies the data, we get none back. What do I mean by that? Well, all my string methods, because strings are immutable, strings cannot be changed. And so if I invoke a method on a string, I've got to get something back. I've got to get a value back. S.upper can't change S because S can't be changed. It's immutable. But if I say S.upper, I'm going to get back a new string. But what if I say mylist equals 10, 20, 30, 40, 50? And now I say mylist.append 60. Will it return something? Actually, no. This returns none, which means it actually is returning something. Fine. It's returning something, but it's returning the none object, which represents nothing. Sort of an existential sort of problem. So now what? So my list has changed. See, my list actually has 60 on it. So we have to distinguish between whether the method changes the object or whether the method returns a new object based on the original object. So in the case of strings, it has to return a new object. That's the only way it can work. But if we're using lists, well, lists are mutable, and append changes the object, so it will return none. Where do I see people getting bitten by this? Well, first of all, I all the time see people doing this. Let's do a mylist equals 10, 20, 30, 40, 50. And then they say mylist equals mylist append. Bad. Let's even add one more because it's really bad. And some exclamation points. Because now what have I done? So on the right side, remember with assignment, it's always right side before left side. So on the right side, I invoked mylist.append. We added 60 to my list. So far, so good. But what did mylist.append return? It returned none. And we're going to put none into my list. And now the type of my list is none type. It's none. Print my list. Now, this is good if you were worried about how much memory your data was taking up. But in all other cases, this is just bad. This is not what you want at all. And I see this all the time in my courses. So again, the rule is if the data is mutable and if the method modifies the data, it returns none. So I see this with append, I see this with extend, I see this with sort. So if I say like mylist equals, I'll just show you one last example, 10, 30, 10, 30, 10, 15, 20, 12. And I say mylist.sort, great, afterwards mylist is indeed sorted from lowest to highest. But if I say mylist equals mylist.sort, again, you never, ever want to do this. Because now mylist, well, it doesn't even show up. I have to say print mylist. And sure enough, that's going to be none. Because sort, the sort method returns none on our list. Okay, last topic for us to discuss here is attributes and ICPO. I can't tell you how many people don't understand this deeply, and it took me many years also to sort of investigate it, understand it, and see how important it is in Python. So if I say a.b, right, a is a variable or an identifier in fancy Python terms, and that's going to be found via legb. Very good. But b is an attribute. B here, the thing that comes after the dot, is not a variable. Do not confuse it with a variable. A, with no dot before it, is an identifier. It's a variable. B is an attribute, meaning it's an object that belongs to A. The most important thing to understand, though, is that the way that Python looks up variables is vastly different from the way it looks up attributes. Variables it looks up with legb. Fantastic. And we're going to get an error here because there is no A. Fine. But what if I say A equals 10, and then I say A.b? Now it's going to give me a different error. It's going to give me an attribute error. It's going to say int object has no attribute b. Now if you're thinking, wait a second. Dot, does that mean a method call? No. A method call requires parentheses, right? It's a callable. But if you don't call it, then it doesn't get called. You just get the method object back. Besides, an attribute can be absolutely positively any type of data in Python. It can be a string or an int or a list or a set or a dictionary, God knows what. Okay, so a.b, A is a variable, B is an attribute. But then that raises the question of where does Python search for attributes? And that might sound kind of funny, but here, like the attribute says int has no attribute b. Okay, but is that all it does? Because wait a second, if I say here, like s equals abcd, and I say s.upper, does s have an attribute upper? The answer is, of course, my favorite answer, yes and no. So here's how it works, right? So attribute search is done via ICPO. That's my term. I'm hoping the rest of the Python world will adopt it because it's so great and so useful. Okay, just because we need an acronym for this. And that's, I'd say ICPO, not to be confused with 3CPO, right? All right, and then here we have, so it starts off with the instance. We search for attributes on the object itself. So when we said A.B, Python looked for B on A. It looked for it on that object itself. Did it find it? No. But it didn't give up, actually, even though it claims to have. Then it looks on the class of the instance. So where did we see that in action? Well, here, s.upper, because it turns out that methods are not defined on individual instances. They are defined on the class. So when we say s.upper, first Python turns to s and says, do you have the attribute upper? And the answer is no. But then it turns to s's class, and it says, hey, stir, the string object, do you have an attribute upper? And the answer is yes. Okay, then we've got p, which is the parents. Let's say parents, right? And there might not even be any parents because it might go directly to object, which we'll talk about in a moment, of the class, right? And so inheritance. This is how inheritance works in Python. Inheritance works because attribute search goes up and up and up the tree. And so it'll start on our object, then it'll start on the object's class, then it'll start on the class's parent, and then that parent, and then that parent, and that parent. All right, so it'll just keep searching until it hopefully finds the attribute. But the final place it searches is object, the head of the pyramid there. Right, this is like the tippy top of all objects in Python. All objects eventually inherit from objects. I should say all classes eventually inherit from objects. So if I say stir bases, right, and show me, right, and this, show me who you inherit from. And we'll see that stir inherits from object. How about int? Who does it inherit from? Also object. All right, so we can see, what about, set? So far, so good, right? Everyone's inheriting from object. But you don't have to inherit from object. You can inherit from someone, and then they can inherit from you. That's a totally normal, reasonable way to use inheritance. But what's happening then is if you have inheritance, if you have an inheritance hierarchy, it's just using this ICPO rule to find things. Let me show you a brief example. If I say here, class person, def init, self-name equals name, and we do here def greet, self, return f of hello, oops, self.name. All right, so now I can say p equals person, Reuven, p.greet, and now I'm saying hello to myself. Weird, but fine. What if I want to have a class that inherits from? I can say here class employee, say def init self-name, and we'll do a super init of name to make sure that it's inherited, actually setting that value there. And I'm going to say here, and I'm going to do nothing else. Oh, sorry, I forgot to say it inherits from person. That would help, right? So now what's going to happen if I say e equals employee, emp1. Now I say e.greet. It's, oops, sorry, what did I get wrong here? Oh, I forgot. Sorry, just a second. Super init, what did I get wrong? Super init. Right. Oh, sorry, super. There we go. Those parentheses, see, get you every time. All right, so what's going on here? Basically, I created a new instance of employee. So when we said e.greet, Python then went through ICPO. It said, do we have a greet attribute on the instance? No. Do we have a greet attribute on the class? No. Do we have on the parent? Yes. And indeed, then the parent's attribute greet is invoked. We retrieve the method object, and then using the parentheses, we actually invoke it. What about an example of O? Well, then I'd have to go, what if I do this? What if I say here, print P? Super ugly, right? Well, what's happening? What's happening is that we are looking for the dunderstir method. Is only taken from object. So let's overwrite that. I can say here, for example, def dunderstir self return person named self.name. And now all this will continue to work, but now when I say print P, it's going to say person named Reuven. How did it get that? Well, what's going to happen is we're going to say instance, no. Class, no. Parent, no. But object, Yes, actually, that's what it was before. And then we went and we defined it on the class. And because it's first come, first serve, the first one wins, so ICPO, the class wins out then. And now we've indeed overridden our stir method. So these are a bunch of different ways in which we see that Python's consistent. I'll add one last thing here, which is people often wonder, what's with this self business? Why do we need to get self passed to us? And the answer is this consistency. LEGB, local enclosing global built-ins, means that there are only 4 places that these names can come from. Where does self come from? Well, it has to be a local, or enclosing, or global, or built-in. There's no special magic that we can use, or that we want to use for self. And so it was decided long ago that self would simply be a local variable, getting the highest possible priority. The good news then is that we always can distinguish between attributes on our objects and local variables, global variables, and so forth. The bad news is then you have to accept self as a parameter, and then every time we want to access one of the object's attributes, you need to use self as well. I hope that this talk was useful, interesting, gave you some insights into both how Python works and how to teach it. I would love to hear from you. Please do contact me on Twitter. Here, I'll add all these things now. So Twitter, I'm Reuven M. Lerner. So this is Twitter, right? You can contact me on YouTube. I have a channel there which explains. I'm slowly going through the Python standard library. I have, I think, about 50 videos now that explain it. I'm Reuven Lerner there, right? And of course, you go to LearnersCoil. You can get my newsletter. And as I mentioned at the top, we've got weekly Python exercise. I will mention also and Ace Python interviews. Now, I'll mention also the weekly Python exercise and all of my other paid courses, 100% of them. You will look at the prices and you will faint, you will freak out. These are prices for rich countries. The way that I define it is those are the prices for anyone in the 30 richest countries in the world. If you are not in one of those countries, and if you're Godfrey's training, you're probably not, then I give an automatic 40% discount. I hope that will be enough to help out. If it is not, I also give group discounts, and we can work something out if you have a group from Nigeria or any elsewhere that wants to take one of my courses, especially if it's for students or academic use. I want to get the word out on helping as many people as possible when it comes to learning Python. Thank you so much for letting me participate. I would love to hear from as many of you as possible via email, Twitter, whatnot. And I hope to meet you in person one day, either at PyCon in the US. It'll be in Pittsburgh this year. I'll be giving out more t-shirts. I'll have a booth again. I'm giving a talk as well. Or if I can make it to PyCon Africa this year, I will be thrilled. Thanks again, Godfrey, for the invitation. All the best and enjoy the rest of the training.